Welcome everyone to today's video. Um, we want to discuss a concept in the chapter of ray optics. When reflection takes place, how does the light bend? We are going to study that using a sphere. So that sphere is basically polished inside. So if a ray of light gets inside the sphere, we are assured that it will have reflections as many as possible as per the law of reflection. The law of reflection says that if we have a sphere like this, if a light enters like this, uh, it will get reflected at the same angle as it was incident with the radius of the circle. So this means, let's say this angle is some alpha, this angle will also be alpha. So we know if the ray of light enters at an angle theta uh, with the radius vector and it gets inside this sphere, so it gets reflected with an angle alpha. How we find that angle alpha? We connect that point from which light is reflected to the center of the circle, and at the same angle the light will be reflected uh, away from that point. So that is what reflection means. Angle of incidence is equal to angle of reflection. Question here is, if a ray of light enters a smooth sphere like this at this angle theta, how many reflections will the ray of light suffer before coming out of the same orifice, if at all? That is the main point. It won't come out of this orifice at all times. But when it comes out, how many reflections will it take place? So, mainly, uh, the angle which this incident ray subtends at the center, if I want to find that angle, this angle alpha will be equal to theta only, because this is the radius vector, this is the radius vector, and in this triangle, two sides are equal. So in an isosceles triangle, these included angles are equal. So if this angle is theta, that means this angle is also theta. So the angle subtended by such a ray at the center of this triangle, what would that angle be? It would be 180 minus 2 theta. As simple as that. So that means all uh, line segments which are made by this ray will sustain the same angle, which is 180 minus 2 theta at the center of the circle. So we can say that when this complete uh, angle, that is 180 minus 2 theta, its multiple, that is after suffering n reflections, it becomes equal to an integral multiple of 2 pi, that is the complete uh, angle subtended by the circle at the center, then it will come out of this sphere. So this is equal to 360 degree. So this value we can solve for n depending upon the value of theta, but this n we can write as some 360 divided by 180 minus 2 theta. So n must belong to positive integers for the ray of light to actually bounce and come out of the ray, come out of the sphere like this. It's a pretty fun question, small and uh, intuitive. So thank you for joining. Have a good day.